we propose MetricHMSR, a novel approach for metric human mesh and scene recovery from monocular images. The MetricHMR is capable of recovering metric scale, reconstructing human scene meshes, and estimating globally consistent 3D trajectories through independent per-frame processing. The field of human and scene mesh recovery is confronted with several key challenges: the inherent difficulty in perceiving metric 3D information, the prevalent use of complex pipelines composed of multiple interdependent modules, and the limited capacity for fine-grained feature understanding. To address these challenges, we propose the bounding camera ray map and a HumanMoE. This paper makes the following key contributions. First, we propose MetricHMSR, a novel framework for metric human mesh and scene recovery. Second, we propose MetricHMR, which incorporates a bounding ray map and HumanMoE to recover a metric human mesh. Third, we present the human-guided metric depth refinement module that leverages human mesh priors to achieve precise metric depth estimation. Fourth, MetricHMSR achieves SOTA in both human mesh recovery and metric depth estimation. Our framework takes a single image as input. We first generate the bounding ray map from the full perspective projection intrinsics, which serves as a key prior. The HumanMoE module is then employed to achieve feature disentanglement and specialized understanding, leading to a metric human mesh recovery. Building upon this, we introduce a human-guided metric depth refinement module that leverages these human mesh priors to achieve precise and globally consistent metric depth estimation. Bounding ray map. The 3D human pose is intrinsically linked to camera intrinsics and bounding box position in perspective projection. Motivated by this connection, we propose the bounding ray map as an explicit representation for recovering metric 3D human information. HumanMoE. HumanMoE consists of a patch MoE and a global MoE. Each submodule is composed of several MoE blocks. Every MoE block includes one ray expert, one shared image expert, and 4 rooted image experts. Patch MoE is used for allocation and specialized processings of patches, as evidenced by the routing heat map of the deepest MoE Layer 4 image feature on 3D-PW. Different experts exhibit specialization in handling patches corresponding to different body parts. Global MoE is used for the allocation and specialized processing of entire images. The upper section shows the allocation of bounding boxes by a shallow MoE layer, while the lower section shows the assignment of different data samples to a deep MoE layer. Human-guided metric depth refinement. Building upon Map Anything, we leverage metric human mesh as a prior to perform pixel-level depth refinement, ultimately obtaining more accurate metric depth. Here, we present the results of metric human mesh and scene recovery from single images. Here, we demonstrate the results of our metric depth estimation from a monocular image. It is evident that our output achieves closer proximity to the true scale than that of unidepth. We present the temporal consistency of MetricHMR using ground truth depth as the reference. Here, We demonstrate the results of our 3D trajectory estimation. Although these methods all employ per-frame processing, which can introduce temporal jitter, it is evident that our approach is clearly superior to other methods in 3D trajectory estimation. In summary, we propose MetricHMSR, a novel approach for metric human mesh and scene recovery from monocular images. MetricHMSR can regress human pose, metric shape, 3D trajectory, as well as metric 3D scene from a single image. We proposed a novel bounding ray map and HumanMoE. We achieve more accurate monocular metric depth estimation. We have achieved SOTA in multiple tasks. In the future, we will utilize rich internet data, annotating it with MetricHMSR to fuel the development of metric human scene understanding. Thank you for your time.